Okay. So we're going to talk about ground. What is ground? What is ground? Anyone?
It's like kind of the opposite.
Right, I can see that. Okay. Anyone else? Yeah.
The point is 0 volts.
The point is 0 volts. Okay. Good. Anyone else? Yeah.
I know it's like a reference point, like it's used as a reference point.
Oh, that's good. Reference point. Okay. Anyone else? There are many, many ways that you can refer to ground. And none of them are absolutely right. Ground is a relative thing. So what you want to remember, I mean, I would even say ground is worthless for your uses here with electronics. Saying ground is an easy way of saying that's the negative side of my battery. The whole idea of a battery, right? And let's just say we have a simple LED circuit, so resistor and LED. Okay, you're following me? Where's ground? Anyone know? Yeah.
Would it be the bottom of the, below the resistor?
Right. And that would be the standard answer. And if you were to say the resistor is connected to ground, that would be an acceptable answer in that most people would put it here. Most people would, because it's the negative side of the battery. And that's like the easiest way to think of ground is most people like to talk about it as the negative side of the battery. But now where's ground? Who knows? Anyone? Ground's here. Because I drew it there. What you want to remember about ground is it's a place that is so commonly referred to that we give it a special name. Right? It doesn't matter where it is, it doesn't matter where you put it, it's wherever you want it to be. Most people assume it's the negative terminal of your battery when you're doing like battery-based stuff. People usually assume that, but that's not necessarily true. In this case, if you told me that this node is ground, you'd be wrong. Who knows why? Yeah?
You drew it in a different place.
Because I drew it in a different place. You can call anything you want ground. You can call this node ground, you can call this node ground, this node, it doesn't matter. The important thing is you call it out. If you ever use the word ground, there had better be this symbol somewhere on your paper, or some symbol that means something similar. What's the point of ground? Anyone? For your purposes in here, the reason why you might have ground, this symbol, is because let's say you had 10 of these. Let's say you had 10 circuits that were all exactly the same. So I'd have to draw like a battery and an LED resistor. Let's say you had 10 of these, right? And they're all over your schematic page. Well, if you want to have them all at the same reference point, you'd have to draw that, right? Or, and if you had 10 of those, that would kind of make your paper look like spaghetti. Because it'd be all over the place with these wires. Or, you could say, boom. Now everybody knows those are connected. Because it's the same thing. I mean, this could be the letter A, this could be the letter A. As long as these are the same, it's just a way of you communicating these nodes are connected. These wires are connected. And that's the whole thing about ground. Is, you know, if anybody says like, you don't have a ground in your circuit, you'd be like, so? Some circuits don't need a ground. Right? So here, somebody be like, you don't have a ground drawn there. It's like, I don't need a ground drawn there. Because it's not referenced to anything else. It's running from a battery that makes a current loop. And that's really what matters, is where does the current want to flow? And in this case, it's going from the positive end of the battery, through the LED, through the resistor, and back to the negative end of the battery. So you don't need ground in this case. Now everybody would say, here's your ground. Have you hooked up your battery to your ground? That would be something you'd hear somebody say. And those are reasonable things to say, similar to being like, have you ever been to the library? Right? Have you ever been to the New York City Library? Who's been to the New York City Library here? How did you know which library meant? There's like 100 of them in Manhattan. Right? But there's one main one that like everybody refers to as the library. Right? Same thing with grounds. You can put the ground anywhere. You can be meaning about any node. But most people call the main library the library. Just because that's what people say. That's the one everybody talks about. Now I'm going to go through what Blue Stamp students mess up all the time with grounds. And you might hear, like I said earlier, do you have your ground hooked up? And that is, I'm going to draw a circuit for you. Arduino. And then we have a servo. And for those of you that don't know, if your servo needs a lot of power, you need to give it power separately, plus 5 volts. And here we'll give it. You need to give it its own battery. And then this. And then your Arduino has, let's say it's hooked up to your computer over USB. Does this make sense, everybody? So this is your servo, your data line. This is the I/O pin of your Arduino. Will this work? Raise your hand if you think it'll work. Nobody thinks it would work. Who's going to tell me why it doesn't work? Yeah.
There's no ground.
There's no ground. You didn't hook your ground up. Explain to me what you mean by there's no ground. What if I go like this? Is that enough?
No, it needs to be connected to the power source on your, or to the Arduino too.
Right. Right. That's good. That's why it won't work. Who knows? Does anybody have any questions about what we just went over? What he just fixed? Let me explain to you what he just fixed. Without these symbols here, let me ask you something. We got a battery, right? We got the plus side and the minus side. How much voltage is on this minus side?
0.
Really? Relative to what, though? Only relative to itself. It's 0 relative to itself. What about over here? How much voltage is on the positive side? Anyone? Anyone? Nobody? Nobody knows the voltage of AA battery?
1.5.
1.5. But relative to what? The negative side. This side is always 1.5 more than this side, because there's chemicals in here that make that happen. So, what if I put it in backwards? Right? Now I've got a negative 1.5 battery. Yeah? If you put it in backwards, now you got a negative 1.5, but this difference across it is still the same. What about relative to Kevin's computer? What's this voltage relative to his computer if I plug in USB? Anyone know? Who doesn't know? Raise your hand if you don't know. Right. Nobody can know. Because we haven't hooked it up with any wires. Like, if I was to hook it up to the positive side, then this side would be 1.5 volts below Kevin's battery. And then if I hook up his computer to the negative side, this node up here would be 1.5 above. But if you don't know how much voltage is across, for instance, this battery is not hooked up to any grounds up here, you don't know how much voltage is being sent. You can't read this data line. This servo is sitting here and it's saying, I know, if you give me a certain signal, if you give me ones and zeros, I'll move in a specific way. I'll do what you say. You can control me and I'll move, rotate one way or the other, whatever. But this voltage signal needs to be relative to something, and the servo is looking at it to be relative to this point. But the Arduino is sending out data that's relative to this point. And since you don't know that these two are the same, just like you don't know how much voltage this has relative to Kevin's computer, that communication that needs to occur can't happen. It'd be like I'm here talking and we had a student out on that patio downstairs trying to listen to me. I'm saying the right things, he's trying to hear the right things, but we still can't communicate. Same deal here. So what we have to do is we have to put them in the same room. And that's why the ground is so confusing, is because sometimes it means you have to hook up a wire, sometimes it doesn't. Did you hook your ground up? I don't know. It's like saying, is everybody in the same room? Is everybody talking on the same level? And that's what's so tricky about ground, is that it can mean different things at different times. Alright. Any questions about ground? I just threw a lot at you guys. With the ground and everything. No questions? You only want me to talk about it? Anything else?
Yeah, I'm still a little confused, honestly.
Okay. So what makes you confused?
Like the aspect of sometimes you hook up a wire, like physically, like hook up to ground, but then like sometimes just like a thing that's useless, you say.
Yeah, and that's the problem. Is sometimes it acts one way and sometimes it doesn't. So some students, and this will mess them up. Some students will build this circuit with no connection here, and every now and again it'll interpret this signal, but it'll interpret it incorrectly. So it'll like start to move a little bit, right? Because it'd be like somebody downstairs trying to hear me. They might hear a word here, a word there, and a word here, and they'll be like, oh, I think I'm supposed to write down something about voltage, I guess. And so that's what the servo does. And so it might look like it's working for a second. But really the problem is without this ground connected, without this reference point, without everybody talking at the same level, it'll always be garbled and unsure.
So is there like a set way to like tell if you need like a wire physically connected?
So the best way to do it is to make a schematic and think of what's going to happen with the electrons. And you got to remember that current and voltage and all works in a loop, right? It's got to start somewhere and come back to itself. So with this Arduino, you're going to send voltage out, right? And it's going to be a small amount of current that's going to go from the Arduino to the servo, right? But then where does it go?
Like right now it's not connected.
Right, so right now the ground's not connected, so there's
Yeah.
nowhere for it to go. So you're going to send a data stream down, which is going to send a little bit of current down this pipe, but then it's got nowhere to go. As soon as we hook up this guy, now the current goes through the servo, back to the Arduino, completes the loop. And so what you always want to do when you're making a schematic is think, can my current make loops everywhere it needs to? So in order to make this data line to work, it has to go from the Arduino through the servo back to the Arduino ground and back to where it originated from. Yeah?
So if you added a capacitor, would you not need the ground for like a limited amount of time?
You want to show me where? I mean, the answer is no, but...
Like where the ground is in the servo. Like,
so if I took this wire away and I added a capacitor here and a capacitor here, but then...
no, but just not the servo though, because all the current would just go to the capacitor.
So yeah, all the current would go to the... So you would send this down here, and then all the current would go here, and it would charge this capacitor,
Yeah.
but it wouldn't return back. So your loop's not complete, right? Sometimes, if you had the signal moving really, really, really fast, you could make this connection here, but it would be silly to do. Why wouldn't you just connect the grounds with a wire? But you see that this is the end of the line for this current. Any other questions? Does that make sense? It's all about the loop.
Yeah.
So the whole thing about ground is an easy way of talking about the wire that we connect to complete the loop. That's what ground is. Any other questions? Yeah.
Would you send it from the Arduino ground to the battery or to the servo?
Yeah, this is kind of a, I suppose you would take it all the way to here, to this ground. That would be acceptable. Because this servo ground here is, it's all the same place. But you're right, that would have been more clear if I would have drawn it. It would have been more clear if I drew it like this. So it goes from here, and then it goes from here. Back in. Does that make more sense? Okay. Any other questions? No? Hang on. The other thing that you might want to think about with ground is there is a absolute ground that exists in this world. It doesn't really affect us here at Blue Stamp because most of our stuff is battery powered. But if you want to, you can take a 8-foot section of copper and drive it into the ground, earth, and that is called earth ground. It's got a slightly different symbol. That's earth ground. And so when you have ground coming out of those outlets, that third plug, that round one, the third one, that's sometimes there, sometimes not, that's earth ground. And so that's something that people use when they're doing like telephone transmission lines, or I guess they make their own ground, but if you wanted to communicate over long distances and you wanted to run only one wire, because you know wire's expensive, you could stick an 8-foot copper rod in the ground and then use that as your ground, because electricity can't flow through the earth. And that's why it's called ground, is because back like 100 years ago when they were playing with electricity, or 200 or 300 years ago when they were playing with electricity, they're like, oh, I don't have to put a second wire for the return path, I can put it through the earth. I can put it through ground. And that's a name, that's why they got a name from ground. Some people call it return now. They call it ground because they used to put current through the ground. Yeah?
So like the entire ground is like electrically charged because of that?
Well, it's not charged. Remember, it's all about, it's just reference. So it's all the same reference point. It's all, if you put a stake in the ground here and a stake in the ground on the Lower East Side, they would be at the same potential. Now it's not it's not as good as connecting with copper, so you wouldn't be able to do like real fancy communication stuff, but it's about the same voltage, so you could talk. Any other questions about ground or capacitors? No? Nothing? Alright, good. If you think of anything else, feel free to stop by, let me know. I'd be happy to talk to you about it. But that's it.